Hello. Hopefully everything's working. Yay! Okay, I think it's working. Also, so you know how my PNG it didn't have any features? I have a thing now where I start off by not having features and I do this. It's really stupid, but anyways, excited to learn AP College Calculus section AB. I know there's like a BC thing as well. I have not started really. And another thing is, I know that there are videos. I'm I'm not sure if I will play them because copyright stuff. I know it's Khan Academy, so everything's like free and open source, but I'm still not very sure. I am too close to my microphone. Yeah, and I have scratch paper. If you need it, I use scratch paper. Now they'll just stay there and they'll stay hidden until I actually get to it. Eventually, I kind of do want to finish the entire Khan Academy course of Calculus, AB and BC. We're just going to start with limits and continuity. I actually do kind of remember this a little bit. Yeah, I did a little bit just so I could test it out, make sure everything was working properly. Here's the thing, I didn't even play the video. I don't know if I will get copyrighted. What if I just muted it and then just used the closed captionings? I don't know. But for limits, I think it's easy enough, or I remember enough where we can just go to the article and I'll just read the article and then feel like I can understand. We're just gonna start with limits, the basic part of calculus, if I remember the basis. Yeah, let's go. We're gonna learn. Are you ready to learn about limits? Okay, to understand what limits are, let's look at an example. We start with the function f of x is equal to x plus 1, or x plus 2. I can't read. So this is the function. Okay, the limit of f of x at x equals 3 is the value of f. Okay, sorry. I can't read. The limit of f at x equals 3, so right here, is the value of f approaches as we get closer and closer to x equals 3. Graphically, this is the y value we approach when we look at the graph of f. And get closer and closer to the point on the graph where x equals 3. For example, if we start at point 1, 3, 1, 1, 3 on the graph until we get really close to x equals 3. So 1, 3 and then x equals 3, our y value, the function's value, gets really close to 5. Similarly, if we start at 5, 7, and we move to the left until we get really close to x equals 3, and the y value again is really close to 5. So it approaches 5, is what I'm assuming that they're trying to say, from either direction. For these reasons, we say that the limit of f at x equals 3 is 5. You might be asking yourselves, what's the difference between the limit of f at x equals 3 and the value of f at x equals 3? So yes, the limit of f x equals x plus 2 at x equals 3 is equal to f3, but this isn't always the case. To understand, let's look at a function g. This function is the same as f in every way except it is undefined at x equals 3. So the little circle thing, it's a little hole. Just like f, the limit of g at x equals 3 is 5. That's because we can still get very, very close to x equals 3, and the function values will get very, very close to 5. So the limit of g at x equals 3 is equal to 5, but the value of g at x equals 3 is still, or is undefined. It's still undefined, so they're not the same. I do remember this part. Alright, this is... Oh wait, that's the beauty of limits. They don't depend on the actual value of the function at the limit. They described how the function behaves when it gets close to the limit. This is the graph of h. Ooh. Okay. What is a reasonable estimate for the limit of h at x equals 3? We go here, x, and then it's 2, but it's undefined at x equals 3, but the limit is still 2. I think, yes. Let's check. Yay! Woo! Alright. Oh god. I remember seeing this. We also have a special notation to talk about limits. This is how we would write the limit of f as x approaches 3. The limit of function f as x approaches 3. Okay. The symbol lim, or limit, I assume, limit of, means we're taking a limit of something. The expression on the right of lim is the expression we're taking the limit of. I was never good at math. I will learn through you. We can learn together. I have to, relearn this. It's been many years since I even touched any of this. But this one, I feel, because it's, very visual, I feel like I could get this really easily. The expression of x as it approaches 3 that comes below the limit symbol means that we take the limit of f as values of x approach 3. This is the graph of x. So the limit, what is the reasonable estimate for the limit of f of x as it approaches 6? Alright, so way that I look at this, so I find where 6 is, and where it approaches 6, so... But there's a thing here. But I still assume as it approaches... Because technically, 6 would equal -5 with this dot here. But... Is it -3? I'm not sure. X means the limit of f values can I speak? Limit of f as values of x approach 3. So it should still be -3 because it's approaching, although the value of 6 is actually -5. I think? Okay, I'm correct. Let's just click explanation, just in case. As we get closer to x equals 6, the function values get closer to -3. Therefore, a reasonable estimate for the limit of f of x approaching 6 and f of x is -3. Alright, which expression represents the limit of x squared as x approaches 5? As x approach 5. So it's not this. I'm assuming x... Probably this one, because the x is approaching 5. It's not like x squared is approaching 5. And then this is the function. So x squared is the function. Yay! I'll just click all the explanations, because why not? Yeah, the limit of the function x squared as x approaches 5. In limits, we want to get infinitely close. What do we mean when we say infinitely close? Let's take a look at the values of f of x equals x plus 2. As the x values get really close to 3. Okay, so getting close to 3 and it gets closer to 5. Remember, since we're dealing with limits, we don't care about f3 itself. We can see how when x values are smaller than 3, but become closer and closer, the value of f becomes closer and closer to 5. Okay, and then we can see how when the x values are larger than 3, but become closer and closer to it. So wait, this gets smaller, so it's like a curve? I think it's a curve. We can also see when the x values are larger than 3, but become closer and closer to it. I read that already. The values of f are become closer and closer to 5. Notice that the closest we got to 5 was with f of 2.999 equals 4.999 and f 3.001 equals to 5.001, which are all 0.00 units away from 5. Oh wait, no, this is more. Okay, then it's not a curve. I read this backwards. This is an increasing order, and this is in descending order. Need to look at the x more. We can get closer than that if we want. For example, suppose we wanted to be 0.00001 units away from 5. Then we pick x equals, I'm not going to say that. And then I guess the estimate is this. This is endless. We can always get closer to 5, but that's exactly what infinitely close is all about. Since being infinitely close isn't possible in reality, what we mean by limit f of x as it approaches 3 is equal to 5 is that no matter how close we want to get to 5, there's an x value that's very close to 3 that will get us there. Alright. If you find this hard to grasp, maybe this will help. How do we know there are infinite different integers? It's not like we've counted all and got to infinity. We know when they are infinite because for any integer, there's another integer that's even larger than that. There's always another one and another one and another one. Alright, so I got a warning that says like audio bitrate stream something. Is my audio okay? Is everything okay? I will keep going. In limits, we don't want to get an infinitely big, but infinitely close. When we say the limit of f of x is equal to 5 as x approaches 3, we mean we can always get closer and closer to 5. Right. Okay, thank you for confirming. I was a bit worried. It does this a lot. I'm not sure why. But every time, people always say it's fine, so I guess it doesn't matter. Alright, what is a reasonable estimate for limit g of x as x approaches -7? We can say it approaches, so 7 should be here in like the middle. So I'm assuming, so this is a natural curve. I would assume it to be because this is greater than that, and it goes down. And this is greater than both sides. And -7 is not even, like, I'm trying to, like, visualize this in my head. So, the way that, like, I see this is where the scratch paper comes in handy. Oh no, I'm blocking. I didn't, like, not block the question. Let me scroll up a little bit. There we go. So if I have, like, really negatives, and then let's just say, like, this is -7, something like -6. It's not scaled. And we'll say, like, 6 is here. So at, like, -7, it goes, like, down. And then, yeah, it goes down and then it goes back up. So well, okay. This is a horrible picture. Can I do this? What if I did this? Can I move it? I can't. I don't know how to do this. That's the wrong button. That's also the wrong button. Stop. Oops. Okay, there we go. I fixed it. Like these, I assume. But I do believe that it's 6. That's how I think of it. Check the explanation. As the x values increase towards x equals -7, the g of x values seem to approach 6. It's close to 6, and also close to 6. As the x values decrease towards x equals -7, the g of x values seem to approach 6. So, reasonable estimate is 6. Yay! Yay! Let's analyze the limit of x squared as x approaches 2, which is the limit of expression x squared when x approach. Okay, I just said that. We can see how when we approach the point where x equals 2 on the graph, the y values are getting closer and closer to 4. Yeah. So even on the other side, it gets closer to where y equals 4. I have my scratch paper up. I need to get used to this. I'll show the graphs again. So this is the function, the limit of expression, and we analyze this, and then we need to see the point where x equals 2 on the graph. So x equals 2 is here, and it approaches 4 from both sides. Like this side, then we'll go like this side. You can also look at a table of values. So when it gets close to 2, it gets close to 4. And from the other side, so this is from the increasing side, and this is from like the decreasing side, from 2.1 to getting close to 2, it is also close to 4. We can also see how we can get as close as we want to 4. Suppose we want to be less than 0.001 units from 4, which x value close to x equals 2 can we choose? Let's try 2.001. So we get this, and that is not close enough. Wait, is it? that's more than 0. Yeah, it's not close enough. Is this the 4? Not a 1 here, or less than a 1. That's more than 0.001 units away from 4. All right, let's try another one. So this value, and we are close enough because it's 0 in the tens, hundreds, thousands place. That's close enough. By trying x values that are closer and closer to x equals 2, we can get even closer to 4. In conclusion, the limit of x squared as x approaches 2 is equal to 4. A limit must be the same for both sides. Coming back to f of x is equal to x plus 1. As the limit f of x approaches 3, we can see how 5 is approached, whether the x values increase towards 3, which is called approaching from the left. Oh, that's a nice term. And whether it decreases towards 3. This is called approaching from the right. Now take, for example, function h. Oh, this is an interesting one. The y value we approach as the x values approach x equals 3 depends on whether we do this from the left or from the right. It does change. So I'm assuming from the left is 4, because from here, and then from the right it's 6. But technically, x equals 3 would equal to 6. But when it's approaching from the left, the limit is equal to 4. When we approach x is equal to 3 from the left, the function approaches 4. When we approach x is equal to 3 from the right, it approaches 6. When a limit doesn't approach the same value from both sides, we say that the limit does not exist. Interesting. This is the graph of function g. Wow, okay. Which of the limits exist? So if they don't equal the same value from both sides, I guess they don't exist? So x approaches 3, so they're not from the same. So from the right is 6, and from the left is 3. So that does not exist. So x is equal to 5. They approach the same point, which is like roughly above 4, slightly above 4. So I would say that this exists. 6 approaches from both sides to, I think, 3. So I would say that does exist. 7. 7's a tricky one. I would also say that it does exist because it approaches both sides and goes to the same point, even though x equals 7 is 2, it approaches 4. Let's check. Yay! See the little graphic. I like learning with graphs and visuals and seeing people do it and explain it. I know a lot of other engineers also function like this. It's always like we don't read the instructions, we just do, and that's why it turns out horrible. The y value we approach as we approach x is equal to 3 is different for each side. Yes, so therefore the limit does not exist. And for this one, it's 6 and it approaches both sides. Same thing with the other ones, so all of those exist. Alright, we finished the introduction to limits. Are you ready for the next exercise? Ready to practice? Alright, let's go 4 questions. Function h is defined for all real numbers. Yes, it is. What is a reasonable estimate for the limit of h of x? So I'm assuming this is as x approaches 0. Ooh. Brain hurting, but ready. Let's go, let's go. Does hurty. So, from the graph, I'm going to assume that it equals 2, because when x is 0, it's like right here, 0. But the graph itself approaches 2 from both sides, even though x equals 7, technically. So I'm going to click that one. You ready to check? Oh, I should maybe display my chat box. First time I've displayed it in a long time. Alright. Check. Oh god, that was so loud. Okay, sorry. I need to lower. That genuinely scared me. I need to lower down my volume. Rec selected! Yay! Does chat understand why it is equal to 2? Alright, I'll go to the next question. Let's see. Function of f is defined. Yay, congrats! Congrats then. Congrats on getting it correct. The function of f is defined for all real numbers, alright. What is a reasonable estimate for the limit of f of x as x approaches -5? Oh, so approaching from the left, it will equal 6, and approaching from, that's the left, right? Yeah, okay, approaching from the right, it will equal -4. But because they are different, because y is equal to 6, and 4 is equal, and approaching from the right is equal to -4, it does not exist. I guess my chat box isn't working. I don't know. I'm not sure. I'll fix that another time. Yeah, so I think it doesn't exist because this value and this value is not equal to each other. Yay! Good work! You got it. Onward! Oh, okay. This is gonna be harder for me because I like seeing the graph. But the function g is defined over the real numbers. This table gives a few values of g. What's the reasonable estimate for limit g of x as x approaches -8? So, -8 should be, yeah, right here in the middle. So it goes, so it increases. Oh, you're packing? Yeah, also, I'm on, like, normal latency. Sometimes I would stream on low latency, but I don't think I moved, and I don't think the internet can handle it. I think it would just explode. The function g is defined over real numbers. Okay, got distracted. -8. I get distracted so easily, it's kind of bad. So it approaches 0.01, and so it's still negative. I'm gonna go back to my scratch paper and try to like draw it out so I can visualize it. So I'll draw that one here. Here. And here. I want to see what -8 looks like. Oh, that's a horrible 8. And then so negative like, oh, it's negative. Okay, all the way down here. Put like -14 or 0.14, 0.14. So when it's like this one goes like here and then here, and then I'm maybe it does approach 0 because it goes like this. It's negative. Yeah, I think it may approach 0. Read this. I hope if the limit doesn't exist, I don't know. I'm just gonna go with my gut. Okay, it is 0. Next question, our last question for the limits, for this particular limit section. There's more limits later. The function h is defined for all real numbers. What is a reasonable estimate for limit h of x as x approaches -1? So from the left side, it will approach -3, and from the right side, it also approaches -3. So assume that it is -3. Yay! Right, show the summary. Awesome, you level up. Whoa, there's confetti! That's actually really cool. I, once again, gotta skip the video. Because I don't want to get copyrighted. I am worried that it will get copyrighted. We're just gonna go to the article again. Hopefully I know enough where you can understand it. Estimating limits. Limit values from graphs. There's an important difference between the value of a function, between the value a function is approaching, what we call a limit, and the value of a function itself. Yes, we learned this in the previous section already. Graphs are a great tool for understanding this difference. In the example above, we see that the function value is undefined, but the limit value is approximately 0.25. Just remember that we're dealing with an approximation, not an exact value. We could zoom in further to get a better approximation if we want it. The examples below highlight interesting cases of using graphs to approximate limits. In some of the examples, the limit value and the function value are equal, and in other examples, they are not. Sometimes the limit value equals the function value. So over here, as x approaches 1 for both sides, that's like -1.4, but it's not undefined, so I'm assuming that x, wait, that's 1. Yeah, okay, it's not -1. Approaches 1 is 1.4. And I'm assuming that what this lesson is trying to tell us. And in this case, the actual value of x equals 1 is also -1.4. But sometimes the limit value does not equal the function value. whenever you're dealing with a piecewise function. Oh no, I remember hearing about this. Piecewise function. I don't like that. What is a reasonable estimate for the limit g of x as x equals 1? I don't really remember exactly what this means, but I've heard this term like way too many times when I was younger. What is a reasonable estimate for the limit of g of x as x approaches 1? So the estimate of the limit itself should be like 4.2. But the actual value should be 1.9 or something. Big takeaway, it's possible for a function value to be different from the limit value. And just because a function is undefined for some x value doesn't mean there is no limit. Doesn't mean there's no limit. Okay. Holes in graphs happen with rational functions, which become undefined when their denominators are 0. Here is a classic example. This is a graph of y equals x over sine x. Notice there's a hole at x equals 0 because the function is undefined, right? Because sine x or sine 0 is 0, which is why it's undefined. In this example, the limit appears to be 1 because that's what the y value seems to be approaching as our x values get closer and closer to 0. It does not matter what function it is. It does not matter that the function is undefined at x equals 0. The limit still exists. Here, try another problem. Here's another problem for you to try. I can't read. So, as f of x approaches x equals -4, -4 is here. It's undefined at -4, but it still approaches like, I can't tell, is that 3.8, 3.3? I think it's 3.3. Yeah, I would say it's 3.3. So it approaches 3.3 from both sides, even though there's no, or at x equals 4, it's undefined. Yay! Reinforcing the key idea. The function at x equals -4 is irrelevant to finding the limit. All that matters is figuring out what the y values are approaching as we get closer and closer to x equals -4. On the flip side, when the function is defined for some x value, that doesn't mean that the limit necessarily exists. Just like an earlier example, this graph shows the sort of thing that can happen when we're working with piecewise functions. Notice that we're not approaching the same y value from both sides of x equals 3. What is a reasonable estimate of the limit of g of x as x equals 3? So, does approach 4 from the left and approaches -3 from the right, but because they're not the same, it should be, it should be that the limit does not exist. Yeah. Graphing calculators are pretty slick these days. Desmos. I haven't really used Desmos. I had a graphing calculator and I think it broke. Like an actual calculator, like a giant Pop-Tart looking calculator. And I'm pretty sure it broke. Desmos can give you a feel for what's happening to the y values as you get closer and closer to a certain x value. Try using a graphing calculator to estimate these limits. You want to graph it out? I mean, I guess Khan Academy already told us the answer to this. Alright, I guess I can't open Desmos. Give me one little second. I'm gonna hide this, just... Freaked. Yeah. This value, so x for sine x. What? But it just said it was, I thought it was supposed to be undefined. All right, there. It is undefined at 0. All right, okay, for the next one. Or do I type in, like, limit? Can I type in limit? Is that a thing? I don't know what I did. I don't like this. Okay, in both cases, the function isn't defined at the x value we're approaching, but the limit still exists and we can estimate it. So if I go x minus 3, how do I use this thing? I'm actually just like a boomer these days. Okay, x squared. Right? Minus 9. They were so expensive. I remember, like, our school would have, I guess you'd say, like, rental ones so that you didn't have to buy a whole one. But I eventually did buy it because, I was gonna go to college and stuff. You use your phone. That's true. Nowadays, people just use their phone. But I know for, like, is it allowed during tests? I feel like a phone has so much other stuff. Oh, 3. Shouldn't be. Oh. Yeah, I was really lucky that my school had, like, rental ones that we could borrow. It is undefined. 3. Maybe it's still required they take it for a test. I guess I wouldn't know. Is it always true that the limit of f of x is equal to f equals a as x approaches a? No, it shouldn't be true because sometimes it could have like that little circle thing where it's undefined. I guess this is an example. Well, this is not a good one because there's no limit, but technically you could go down here and then go back up and have a still undefined circle, and then 3 could be equal to something else. Oh, no. Which statement better describes how graphs help us understand about limits? A graph can help us approximate a limit by allowing us to estimate the finite value y value we're approaching as we get closer and closer to some x value from both sides. Graph is a great tool for always finding the exact value of a limit. Well, it's the first one. Because sometimes, like, the whole point of limits is to get really, really close. Yeah. Next up is exercise. This section is much longer than the previous one. Ready to practice? Okay, show us what you can do. Let's go. The function f is defined for all real numbers except for x equals -3. Alright? What is a reasonable estimate for the limit of f of x is when x is approaching -3. But it's not defined. Undefined. But it goes like up and then it goes down. It goes down from the right side and goes up from the left. I'm assuming the limit doesn't exist. Yay! Yeah, because it doesn't like converge to a single point, even if it is undefined. Okay, the function f is defined for all real numbers. What is a reasonable estimate for the limit h of x as x approaches -2? So this one, just by looking at it, because it like jumps in values from 5 to -6 or something, -6, roughly around there. The limit does not exist because 5 and -6 are different. The function h function h is defined for all real numbers. What is the reasonable estimate for the limit h of x as x approaches -3? So the reasonable estimate should be -5.3. Yeah. And the actual value is like 4 point something, but because it approaches it from both sides, it is 5.3. The function h is defined for all real numbers. Oh, it's a smooth graph. Okay. At x, the limit of this function as x approaches -2. X -2, roughly around -4, so I guess 3.8. -3.8 approaches from both sides. Yeah, I think -3.8. Yay, I got 4 out of 4. Wow, I love the confetti effects. Woo! There's no article. Ugh. No. Alright, do I just go in blind? I wish they had articles instead of video, or like somehow maybe I could confirm on my own if I could watch these videos on stream. And the next one's also video. Right, I'm just gonna jump into the questions. Hopefully, from the previous things that we learned, it should get me through this. Okay, function h is graphed. What is the value of... Oh, what is this plus? That's from the right, I believe. I'm gonna guess unbounded. Because I think... Sorry. I guess unbounded. Okay. I'm gonna mute this and then I'm gonna see. I'm just gonna click through it and use the subtitles for. And I will show up the scratch paper so I could cover a little bit of the screen. Closer from the values. X or 2 subscript of negative. So they're approaching from the negative direction. Okay, so that is approaching from the left. I'm assuming the plus means that I'm approaching from the right. I have no clue at all, but I think it might be okay. It's like a free membership. Yeah, it is true that Khan Academy is like open source. It's meant for like free education. I'm just gonna read the subtitle. And we can see here that it is approaching 5 from the left. But what if we were to ask the natural other question, what is the limit of f of x as x approaches 2 from the right? So this little superscript approaching from the right direction. Okay. YouTube, please, this my own thing. I'm not even monetized, so I don't think it will happen. There. So in this situation, we're getting closer and closer to x equals 1. So when it approaches from the right, approaches 2 from the right side, which is the positive superscript, it equals to 1 on this graph. Right? Is there like another example? So they do not equal each other. I guess that's another point, is that when it approaches from the left and right, it does not equal each other. So it does exist. Oh, the limit of 2 does not exist, but the limits from the right and left do exist. So at 4, it should be -5 for both. Approaching from the left and right, and the limit exists. Yeah, so right side, it's -5. So since they are equal, we know that the limit of f of x, general limit, is -5. Oh, I like how they added a little correction. The limit of f of x as it approaches 8. Let's approach it from the left, so there's a negative superscript, or the minus superscript sign. Closer to 3, and then from the right it approaches 1. But the limit of, as x approaches 8, it should be, does not exist. Yeah. Seems like we're approaching f of x equaling 1. Alright, I'm understanding this. I'm understanding. The limit of f of x as x approaches 8 does not exist, because from the right and left, they are not the same values. Function f of x graphed what appears to be the one-sided limit. So that one should be from the left, so it will be 4. Yes, it is equal to 4. Wait, what is that correction thing? I missed it. Oh, 2 by -2. I think is the guy's name like Sal Khan? Has one of the most like recognizable voices because of his Khan Academy videos. And approaches from the right. So it's also 4, so the limit of f of x as it approaches -2 is equal to 4. Yay. That's what we're gonna do. We're gonna watch this entire thing muted. What I want to do is figure out the limit of g of x as x approaches +6. It's the guy who made this. Sal is the guy who like made Khan Academy. It's named after him. I think his name's Sal Khan, and he's the guy who made like all of these videos on like YouTube and everything about like teaching stuff. From the left, function so kind of just like continues. It's probably because like I watched a lot of these when YouTube was first like a thing. I watched a lot of like stupid. I don't know. This is like not great to say, but I would watch people like pour aluminum into like anthills and stuff, and I would just find that so entertaining. And then I would also watch like these math videos. Okay, so it does approach infinity from the left because it just swoops up. Not. Oh, it does not exist. Okay. As it approaches from the right-hand side. A little less than 3 times. -3. Alright. So from the left, it's just unbounded. But like, is there a difference between unbounded and does not exist? Okay, I'll move everything back. Then back to my little corner. So this function is graphed. It appears that h of x as x approaches -4 from the right. I have not heard of that person ever, actually. Yeehart, I should go check him out. Value, so it approaches from the right to -4, so that's unbounded. Okay. Because it goes there and it just goes to infinity, I assume. Yay! Function g is graphed. What appears to be the limit of value of g of x approaches 1 from the right. Appears to be -5. Little approaches to the -5. What appears to be the value of the limit of g of x as x approaches -3 from the left. Go to the left side, find -3, and it is -6. I'm on a roll. One more question. Function h is graphed. What appears to be the value of the limit of h of x as it approaches -3 from the left. So it should be this way, so it should be 6. Yeah. Yay! I love the confetti. It's adorable. Next up, we have another video. Right. So, as a limit, x approaches 5, g of x is equal to -6. As x approaches 5 from the right, g of x looks like it's approaching 6. A reasonable estimate based on this graph is that as x approaches 5, g of x is approaching -6. It's worth noting that that's not what g of 5 is. G of 5 is 0. The point of the whole video is to appreciate all that a limit does. A limit only describes the behavior of a function as it approaches a point. It doesn't tell us exactly what's happening at that point. What g of 5 is, it doesn't tell us much about the rest of the function, about the rest of the graph. For example, I could construct many different functions for which the limit as x approaches... Okay, that was too fast. For example, I would say the limit of f of x as x approaches 5 is equal to -6. I construct that f of x does this. It looks different than g of x. Function looks like this. Let me draw f of x. And even is defined as something like this. That would work. Yes, it would. Equal to -6. A function like this. It's defined up there, and we have a circle, but then it wouldn't exist, right? Because it's... Oh, it does exist. At x equals 5. Not because it's the same. Oh, interesting. Let me move this like over here. Okay. I can move the subtitles. This function right here would say the limit g of x approaches 1 -5 point. -5.3, 5.2. Okay, so that's equal to g of 1. Because it is not undefined. Yeah, okay. I'm assuming the whole point of this video is to explain that the actual value doesn't equal the limit all the time. They're really drilling that idea in our heads. Ready to practice? Yeah, let's go. Consider the graph. Whoa, that's certainly a graph of function h. Which limit expressions agree with the graph? Okay, so as x approach -1, so it's here from the right side. Is equal to 6? It approaches 6, but it's not. Wait, yeah? I guess it is. This limit does equal 6. A limit for -5 when it approaches from the left equal to -2. It's not 3, so that one's not it. Approaches 4 from both sides. So from the left, -5, and from the right, it is also -5. So I think these two? Yay! Which graphs agree with this statement? Interesting format. As the limit of g of x approaches x equals x as x approaches 3 is equal to 5. So this one, because it's approaching 5 from both sides when x is going to 3. This one as well, even though x or f3 or g3, I guess, g of 3 is equal to 3, it still approaches 5. And then this one, all of the above, essentially. This one also is, it's like the first one. Consider the graph of the function g. Which limit expressions agree with the graph? Let's see. Okay. Equals to 1 from the right side. That is like, that's not correct. It's not -1. That's a positive 1, right? Yeah. 1 from the right side. So that's not -1. So 4 from both sides is indeed, no, it's -3. That's 3. I almost got tricked. I need to be more careful. And then as it approaches -1, so here from the right side, it is equal to 1. So that one's correct. Yay! Consider graphs A, B, and C. Which graphs agree with this statement? As the limit of h of x as x approaches -2 should equal 3. So from both sides that. There's no one side only. That one's not correct because it just does, the limit of -2 just simply does not exist. This one is, that's unbounded. C is the only one because it approaches from both sides to 3. Confetti! Yay! Woo! Lesson 4. We have a new lesson. Is it more limits? No, more limits. Oh, there's an article. I can skip the videos. Limits are a tool for reasoning about function behavior, and tables are a tool for reasoning about limits. One nice thing about tables is that we can get more precise estimates of limits than we can get by eyeballing graphs. When using a table to approximate limits, it's important to create it in a way that stimulates the feeling of getting infinitely close to some desired x value. Imagine we're asked to approximate this limit. Alright, the function is actually undefined at x equals 2 because the denominator equivalates to 0. Why not just say equals to 0 instead of equivalates? but the limit as x approaches 2 still exists. Step 1. We like to pick a value that, I'm losing my voice, that's a little bit less than x equals 2. That is a value that's to the left of 2 when thinking about the standard x-axis. Maybe start with something like x equals 1.9. Try a couple more values to simulate. Simulate. I can't read. Simulates. Simulate the feeling of infinitely close to x equals 2 from the right. That's not even stimulate. I read this wrong. It simulates. They why are they spelled so similarly? I hate English. Sometimes, why is English like this? Try a couple more of x values to simulate the feeling of getting infinitely close to x equals to 2 from the left. Alright, so this is from the right. No, this is from the left. Notice how our x values really zoom in around 2. A worse choice of x values would have been constant increments like 1, 0, or -1, 0, 1, which aren't very helpful for thinking about infinitely close to x equals 2. Approach x equals 2 from the right just like we did from the left. We want to do this in a way that simulates the feeling of getting infinitely close to 2. So 2 would be right here in the middle. We've removed x equals 2 from the table to save space, and also because it isn't necessary for reasoning about the limit value. Looking at the table we created, we have a very strong evidence that the limit of 0.25, so the limit is 0.25. But if we're honest with ourselves, we must admit that what we have is only a reasonable approximation. We can't say for sure that this is an actual value of the limit. 3 students were given a function of f and asked to estimate the limit of f of x as x approaches 2. Each student created a table below. Each table is accurate, but which one is the best for approximating the limit? I'm gonna take a sip of water. Alright. So we need to find it when it approaches 2. This is not great because it's like very far away and in increments. This only has one side. We need it from both sides, so the answer should be B. Yeah. This table does a nice job getting closer and closer to x equals 2 from both sides. Common mistakes when creating tables to estimate limits. Here are several things to watch out for as you create your tables to approximate limits. Assuming the function value is the limit value, the example above highlights a case where function is undefined, yet the limit still exists. Avoid jumping. Why is this in italics? Avoid jumping to conclusions about the limit value based on the function value. Not getting infinitely close. Getting infinitely close means we're trying to get so close to a desired x value that there is very little room between where we are and where the value is, close enough to convince us that the estimate we're getting is almost likely what the limit is. Avoid picking x values in constant increments, or even these, because those values don't really get us infinitely close. They only get us kind of close. To get infinitely close, you want to keep reducing our increments using values like these, so that we're shrinking the space between where we are and where we'd like to be. Not approaching from both sides. Remember, to approach your desired x value from both the left and the right. Remember, for the limit to exist, the left and the right hand limits must be equal. Avoid jumping to conclusions about the limit value after only approaching your desired x value from one side. Assuming left side means negative, some students mistakenly believe that when approaching from the left, they must use negative numbers. In the example above, we approached x equals 2 from the left by using positive values that we're just a little bit less than 2, such as 1.9 and 1.99. Don't assume you must use negative x values when approaching from the left. The function g is defined over the real numbers. This table gives select values of g, okay? 4 goes to 5 goes to 6. Oh, it jumps. Interesting. So that's what they were trying to do. What is a reasonable estimate for the limit of g of x as x approaches 5? So it is approaching, so this increases to this value, and then, wait. No, okay, yeah, this increases to this value. Like, goes up, it jumps because it probably has like another value there, but that's not the graph. And then something increases like this. I'm kind of confused. Okay, I'm gonna draw this out. Scroll down a little bit for extra space. So let's have a graph like this. It's all positive. Let me like 5. 5. And then what's 4, it's like lower. 3, then it increases. And I'm assuming there's like a undefined thing here and it like jumps up some value. And then it goes back down? No, it goes down then up. Like these, I guess. Something like that. I don't know if I'm correct. I think that's what I'm supposed to be doing. Let me hide that. What is a reasonable estimate? So I don't think it's that. I think it could be 4. Because it increases. Oh. I'm gonna go with 4. I don't know if it's correct. It's incorrect. Okay. From the table values, it appears that g is increasing, so we would expect to be between. Alright. It should have been that one. So it didn't jump, it just stayed. I guess it should have looked more like this, with a flat line, and then it goes up. Common mistakes when estimating limits from tables. Confusing the limit value with the function value. Remember, the limit of a function at a certain point isn't necessarily equal to the function value at that point. For example, problem 2, g of 5 is equal to 6.37, but the limit is about 3.68. Thinking a limit value is always an integer. Some limits are nice and have an integer value or nice fraction values. For example, the limit to our first problem for our first example here was 0.25. Some limits are less nice, like the problem in 2, which is somewhere around 3.68. Summary questions. A student created a table to help them reason about the limit g of x as x approaches 7. Based on the table, what can you reasonably conclude about the limit? In between these two values, let's see, 1.25. This one seems reasonable. The limit does not exist. No. Appears to be asymptote. No, because these are close enough. As we approach x equals 7, the value of g of x definitely approaches exactly. That's a weird way to say it. Yeah, okay. The table gives a few values of function f. The function is increasing everywhere except at x equals 5. And the limit of f of x as x approaches 5 exists. Table gives a few values of, okay, so find the reasonable limit. So in between these two? But I feel like this is reasonable. I'm confused. Table gives a few values of f of x. The function is increasing everywhere except... Oh, it goes down. It increases. Oh, okay. I understand. So it should be 5 point... So it should be above this. And below that. 5.3, then I assume, I think, maybe 6, because that's lower. That's also lower, and that's too high. I got it correct. Yay! Let's go! Question time. Given the function f and asked to estimate the function of f of x as x approaches 5, 3 students create a table. Which table is the best? This has it from... That's too far away. It doesn't have to be negative. This one. 5 fits right here. And you have one from the left, which is like the 4.995, and one from the right, which is the 5.005. Yay! The function g is defined over the real numbers. The table gives several values of g. Is the table appropriate for approximating g of x as x approaches 4? If not, why? Let's see, 4. I would say it is. The table is appropriate. From one direction, it is approaching it from both directions for constant. I would say table is appropriate. Given the function g and asked to estimate the limit of g of x. Alright, so another one of these. Which is the best table? 4. Why are these all negative? I think this one. Yeah, because this is only from one side. This is from both sides. The function f is defined over the real numbers. This table gives several values of f. Is the table suitable for approximating 9? It's all in increments, though. It's in both directions. Yeah, the table is not appropriate. Yay! 4 out of 4 correct again. Another exercise. Let's go. The function f is defined over the real numbers. This table gives select values of f. What is a reasonable estimate for the limit f of x as x approaches 6? So, well, they said it should be in between this one and this value. Assuming this one. But it, like, I don't like it when they're like the same value. There's no way it's this one, or that one, or that one. But I feel like it should exist. Okay, I'm just gonna go with B and hopefully it's correct. It is! The function h is defined over real numbers. This table gives a few values of h. What is a reasonable estimate for the limit of h of x as x approaches -7? Um, 7 in between here should be in between these two numbers. The 3. -3. I believe. Yes. Right, estimate the value of the limit of as it approaches 1. So use a graph. 1 should be right here. Whoa, it jumps a lot. Okay, so this increases and then decreases? But it should be in between the two values. So, ooh, there are two values that are in between. Wait, no, there isn't. There's only one value. Why did I think 7 was in between this value? I think I'm losing it. It should be 8. What? Try again. I will try again. In between the two values. This increases. And this decreases. Does it not exist? Alright. Dang it, I got one wrong. Oh well, it's fine. I'm assuming it's like that because it jumps. It has to jump. It's like too far from each other. That's why I think that thing is there. Okay, so final limit when it approaches x to 0. When x approaches 0 of this table. Is this another one? This increases and this decreases. They are close to each other. How do I think about, like, I'm confused. So it's definitely not the first two. It could be another, the limit does not exist. Because then this increases. And then if I do this, then it would like decrease a lot and then it would increase a lot. This just doesn't seem right. And if I put this, then it would just keep increasing and then it would jump anyways and then go to like, or jump back down. Okay, I might get this one wrong again. Okay, as x increases, f increases. to the left, decreases to the right. There's no evidence of the function jumping. There's just increases like this. No, I didn't do too well. I didn't get confetti this time. That's tragic. Wait, I had my scratch. What happened to my thing? I had my scratch paper on the entire. No, I'm dumb. I'm so dumb. I'm sorry. I had it blocking the entire screen. I'm actually so stupid. You know, I think I'm gonna end stream here. I will redo that one the next time I stream this without the scratch paper in the way. I'm like Ashley. I can't. I'm so dumb. How did I not notice the entire time? I did all of this with the thing blocking the question. Well, I'm not only a failed engineer, I'm failed in other ways as well. Failed streamer. Well, anyways. I think I will end Khan Academy learning here, but I do want to mention that, well, like 2 big things. My stream schedule is going to change kind of like drastically within the next few weeks. I'm not exactly sure. And then it will settle down again because I got a new job. And I got to figure out what's happening. I got to figure out what's happening with that, and like I need to figure out my schedule. And then on next Saturday, I will have my 1-year anniversary of streaming. Technically, my 1-year anniversary is on Monday, but I have to work, which sucks. But I don't know if anyone else saw, if you have an original character, anything you would like me to horribly draw, or I mean, like beautifully draw, just like my scratch paper, you can like go to that pinned tweet I put in chat. I'll also add it to the description if anyone like is watching the VOD or anything. Yeah, I only have like 2 people, and I think one of them is a bot. I know Yoshio submitted, but yeah, boo, work. I want to work. I want to lay down. I want to stream more. I want to see how my brain can melt. But yeah, so I'm probably gonna draw like some stuff. I don't know how long it's gonna be. I would assume like it's really shitty, okay? So like don't expect much. I mean, you can see an example on the tweet. But yeah, I only have 2 people so far. So if anyone else wants to add their stuff, don't feel pressured to, but I'll be greatly appreciated. And on June 1st, I'm also going to do an unarchived karaoke stream. It's going to be all a cappella with no like background music. It's going to be bad, but that's why it's unarchived. I don't know what time yet, but I'll have it scheduled probably by like Tuesday. I know it's like super late, but I'll have that scheduled, and then maybe I'll do like a collab. I'll set a collab up. If not, I can play with viewers as well. Like Balloons League. I have League. Balloons. Yeah, thank you for coming, and thank you for watching. Thank you for learning with me. See you hopefully on Saturday next week. If not, don't worry, the VOD's gonna be there, except my karaoke. It's also, honestly, it's kind of better that you don't go. I still have a fear of like singing on stream, and it messes up with my breathing, which is not good when you're singing. But anyways, yeah, bye. Thank you for coming. Have a nice day. Have a nice week. Bye, everyone.